Greetings, math scholars. Welcome to our Week 5 videos on graphing systems of inequalities. So the upside to this week is we're going to be using a lot of skills we already know because graphing inequalities is very similar to graphing lines, but there are a couple of important differences. So the first difference is we have to make a decision what kind of line we want to draw. If we have a less than or greater than symbol in our inequality, we want to draw a dotted line. This tells us that points on the line are not part of the solution. If we have a less than or equal to, or a greater than or equal to, we want to draw a solid line. This tells us points on the line are included as part of our solution. So that's the first difference. The inequalities will still be in slope-intercept form, and we'll graph them the same way. Identify the y-intercept, use the slope to find your second point. The only change is now sometimes you're drawing dotted lines, sometimes you're drawing solid lines. The next difference is there is an important step after drawing and labeling your lines. Each inequality represents an area in the coordinate plane. We are going to need to choose a test point to decide which area to shade in. When you choose test points to decide which area to shade in, you should not choose a test point on the line itself. What we're looking for is where is the area in the coordinate plane that makes that inequality true. We want to shade in the area that makes the inequality true. Once you've done this process of graphing and shading for both inequalities, the solution to that system is the area of overlap. It's the area that you shaded in for both inequalities. What I like to do when I do this process is use two different colors, one for the first inequality, a very different color for the second inequality, so that that area of overlap is very clear. I can see where those colors mix. I like colors like blue and yellow, for example. It's very clear when they make green. Or red and blue, very clear when they make kind of a purpley color. But colors that are very different make it easier to identify that area of overlap. Before we do some examples, I want to kind of point out how this connects to something we've done before. So over on this side, we're looking at inequalities in two variables. Instead of y equals mx plus b, we're going to have y is less than or equal to mx plus b, or y is greater than mx plus b. We are looking at a relationship between x and y. When we saw inequalities in first semester, we were looking at statements like x is less than 2. Lots of similarities in how we approach that. For one variable, we drew a number line instead of a two-coordinate system where we had x and y. And then, we had to make some decisions about how we represented that inequality on our number line. So let's do that for this inequality and compare what that looks like to what we're going to do now. So if I wanted to represent x is less than 2 on a number line, the first thing I'd have to do is look at that symbol here and decide filled in circle or empty circle. In this case, I would use a an empty circle because there's no equal sign underneath. That empty circle is equivalent to the dotted line we're going to do now. A filled-in circle is equivalent to the solid line we're going to do now. In this case, empty circle because there's no equal sign, it's just less than. So I'm going to make an empty circle at 2. The next thing we needed to do was shade in the direction of that inequality. I want to shade in all of the numbers on the number line that make that inequality true. So I'm looking for numbers less than 2. Well, less than is to the left. So I'm going to grab a highlighter and I'm going to highlight areas to the left of that point. What I've done is I've divided my number line into a region where the inequality is true, 0 is less than 2, minus 3 is less than 2, 1.99 is less than 2, and regions that are false. 2 is not less than 2, 4 is not less than 2, 100 is not less than 2. We're doing the same thing with inequalities, except instead of half the number line being shaded in, now it's half the coordinate plane. In our next video, we're going to take a look at how that translates in a couple of examples. So if you have questions on what you just saw, please let me know. Otherwise, I'll see you with our first example.